Hi everybody, I'm going to talk tonight about the next section that we're going to do. It's actually the last section before we are done with this unit on radicals. It's kind of a small unit, but it seems like it's packed with a lot of new information. So we are talking about imaginary numbers tonight. An imaginary number is really the square root of a negative. It has no tangible value. They're also called complex numbers. In the real world applications, they use them in electricity or quadratic equations, things like that. So let's get into the two basic things that you need to know about imaginary numbers. So I've written them in this order, but really not for any good reason. I'm going to talk about the I first. The I just equals the imaginary number, which we will define as the square root of -1. If you were to square this, square, you would get -1. I squared equals -1. So these are things that you need to know when we go to simplify these and work with these. The values 6i, 2i, and I radical 3, these are all imaginary numbers. You'll notice when I write my I write it with a little bit of a cursive, a little bit of a lean to it. Some people write it like this. You'll see others write it kind of like that. I tend to do something like this. So what that allows us to do is it's going to allow us to simplify some things we were not allowed to simplify before. For example, square root of -18. I automatically, every single time, I don't always show this step. Oops, that's supposed to be a positive 18 now. But I want to remove the negative from the situation. So I call this taking the I out. The I equals radical -1. So I'm going to remove that. And now I can break this down like I always would. So this simplifies into 3i radical 2. You'll probably show that in less steps than I just did, especially as you get good at this. But that's basically what's happening. So the next problem we have is radical -100 x cubed. Once again, I tend to take that I out right from the beginning. I know it's a negative sign. I'm going to put it on the outside. Then I'm left with this. Well, I know the square root of 100 is 10. So I still have my I. And then I know that x cubed is going to break into this. The more experienced you get with these, the less work you're going to probably show. That comes out as this, and then we're left with that. You can write it in this form or like that. These two things are exactly the same. Okay, I've seen it written both ways at this point. And the last example in this little part is, I'm not really changing it up very much here, but I got the square root of -90, which just equals, well, if you want to show that, go ahead. This is going to break into that. So really we're taking out an I, we're taking out a 3, and we're left with the radical 10. Okay? Going back over to this example here, make sure you always write the I before the radical sign. You don't want to confuse it and write it after, because then you can't really tell where it goes. So it always goes right with the number there. So, chart you need to memorize, but you get used to seeing. If you know I equals radical -1, you know I squared equals -1. Let's think about what I to the third would be. Well, I to the third would be basically I times I squared. Hey, look at that. I to the third equals negative I. And let's think about what I to the fourth would be. Well, I to the fourth would be I squared times I squared, which I know is that. Well, there you go. This is a pattern right here. Let's see if I get my different color. Hold on, pause. So if I ever say, what's I to the fifth power? You'll tell me that answer right there. These are the answers you'll always give. You'll never give this answer because this is not simplified form. You'll always say I. But for the rest of them, once we start increasing the exponents, you're going to write what its value is. So if I said to you, let me put my pen down again, hold on. What is, let's say, I to the 36th? Well, this is I to the first, I to the second, third, I to the fourth, I to the fifth, I to the sixth, I to the seventh, I to the eighth, I to the ninth, I to the 10th, I to the 11th, I to the 12th. This is going up in multiples of 4. So if I'm going to do I to the 36, hey, look at that. It's a multiple of 4. I know it equals 1. If I said I to the 47th, well, I would say to myself, okay, I know it's going up by 4s. This would be I to the 44th, I to the 45th, I to the 46th, I to the 47th would be negative I. So you're working with this pattern every time. These are all the multiples of 4 down here. I to the 242. You think that's a really big number? Yeah, I guess it is. But 242, well, I know multiples of 4. I know that 100 is a multiple of 4. So I know 200 is a multiple of 4. So I know 40 is a multiple of 4. So this would be 240, 241, 242. And that's the way I do those problems. So, when you go to simplify anything else like products, well, if I told you to do negative 3i times 2i, you would tell me, oh, that's negative 6i squared. And then you would immediately switch gears and tell me that I squared equaled negative 1, so that equals 6. For something like this, and this is the biggest mistake people make, when you go to do this, you have to take the I out first. You cannot multiply negative 12 times negative 2. This right here equals I radical 12. This equals I radical 2. So I times I is I squared, radical 24, which is equal to negative 1 times radical 4 times radical 6, which equals negative 2 radical 6. So there's a lot more steps to it than you would think. I'm trying to number these here. Sorry about that. And this was the third one. If I had 4i all cubed, I'd get 64i cubed, and I know I cubed equals negative I. So I would get negative 64i. Adding and subtracting, just like you would think. You're going to combine all the i's. I don't really know why I put an I there. It doesn't matter much, but I'm going to change it up a little bit. So this actually says 3i plus 4 minus 6 plus 2i plus 5 minus 3i. Making sure I'm being clean with my signs here and distributing where I have to. So I'm left with 3i plus 2i is 5i minus 3i. And then I'm left with 4 minus 6 is negative 2 plus 5 is 3. So you can combine terms like that. I'm going to stop there. Good luck.